So, good morning, everyone. So we'll just go through this today. Like I said, it's better if the question comes from you. So, anyone? So, does anyone want me to go through any particular questions?
Hello.
Hello. Hello. Good morning. Does anyone want me to go through any particular question? First one to shout out, then I'll go through whatever question you want me to go through. Hello. Hi, everyone.
Question 7.
Question 7.
Disuruh tani cek kapan. Disuruh tani buat loh kemarin.
I can't hear you.
Bisa aja ya.
I can hear you. There is nothing I ask you to do. I just ask you to go have a look at this thing. If you want me to go through anything, then ideally you should have tried some of these questions, and only then you'll be able to tell whether you can do or cannot do. Okay, there's nothing to be submitted, right? Because you have your schoolwork, and A-level is quite heavy as well. So what you're supposed to do to make full use of this is you tell me what question you want me to go through. I go through it for you, and then at least you know how to do the questions now. Okay. Anyway, so in this question, I forgot who asked it just now, but this is carbon disulfide, carbon with 2 sulfur. This is 3 oxygen. This is 1 carbon dioxide and 2 SO2. Importantly, have a look at this gas, 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 and gas. Because everything is gas, we know that the mole of a gas is equal to the volume of the gas divided by the molar volume of the gas. And we know that at room temperature and pressure, as stated in your periodic table, 1 mole of any gas occupy this volume of gas. Because all of them are under room temperature and pressure, under standard condition, I think, under same temperature and same pressure, they will have the same molar volume, So that means if the bottom bit is a constant, therefore we'll be looking at the mole of gas is directly proportional to the volume of the gas. This is the most important thing in combustion analysis. In this question, we burn it in 50 cm of oxygen. So you think about initial, how much you put in. You put in 10 cm of that. So I'm just going to compare volume ratio, because volume ratio is going to be the same as the mole ratio, because they will have the same molar gas constant. This is, sorry, not molar gas constant, molar gas volume. So this is 50 cm3, that's what you put in. And how much do you get out? How much do we get out? This is 1 mole reacting with 3 mole. If you have 10 cm3 of these, you will react with 30 cm3 of, 3 times the volume of these. So if you have all of them reacting, because all of them reacting, so from 10 to 0, so this one, how much is left? 50 is what you put in, 3 times 10, because 3 times the volume reacted, so you're left with 20 cm3 of oxygen unreacted. On the other hand, how much CO2 get produced? If you have 1 mole of CS2, you produce 1 mole of CO2. If you have 10 cm3 of CS2, you will produce 10 cm3 of CO2 as well. Similarly, this is a gas. If you produce 10 cm3 of CO2, you produce double the volume of SO2. So you produce 2 times 10, which is 20 cm3 there. Anyway, these are volume ratio of how much you have at the end of reaction. But this question is asking you, after measuring the volume of gas remaining, you treat it with an excess of aqueous sodium hydroxide. Sodium hydroxide is NaOH. Sodium hydroxide is alkaline. So what happens with alkaline solution is it will remove the acid. Alkali or base remove, or we say neutralizes the acid. Out of all your product, the CO2 and also SO2, they are what you call acidic oxides. These are from your O-level, GCSE or IGCSE level chemistry. So that means all the CO2, all the SO2 will be removed by NaOH. How much SO2 you have? 20 cm3, 10 cm3. So after you add it with NaOH, it will remove the CO2 and SO2. It will remove 10 plus 20, it will remove 30 cm3. But after burning, you have unreacted oxygen. The unreacted oxygen is your 20 cm³ remaining because you only reacted 3 times 10 cm³. You only reacted 30 cm³. You still have 20 cm³ remaining. But then you also have 20 from the SO2. So this is the SO2. And you also have 10, which is the CO2. So you have 50 there, 50 cm³ after burning. But then after adding the NaOH, you remove the acidic oxide. So you remove 30 cm³, you're left with 20 cm³. So the answer should be C there. Okay, does that answer your question? Whoever asked me just now?
Yes, thank you.
This is a maths question, right? This topic is about calculation. You will not do well in calculation if you're just reading. You have to get your head dirty and do some calculation. Okay, next question. Which question do you want me to go through? Anyone? Whatever question you shout out, I'll go through that question. Don't be shy, just shout out whatever question you want me to go through. MCQ, structure, whatever.
Question 5.
Question 5. Question 5. Okay, so we have a shell of chicken egg. If you had chicken egg today, you would know that they have shell outside. The shell make up the 5% of the mass because the rest of the mass are basically whatever are the contents. That is the one that we eat. So an average egg has a mass of 50 grams. So you need to learn to read information. As you process information, people are not very good reader. Naturally, I'm not a very good reader as well. So as I read the question, I need to write down some stuff, otherwise I'll forget, okay? So out of 50 grams, how much is the shell? Okay, because we are interested in the shell, which is pure calcium carbonate, Ca2 plus CO3 2 minus calcium carbonate. So out of 50 grams, the mass of the calcium carbonate is only 5%. Percentage is out of 100%. So 5 out of 100 multiplied by 50. You should have a calculator next to you as well as a predict table. That's the whole point of coming to a tutorial like this. Otherwise, you'll be wasting your time. This is a 2.5 gram out of 50 grams for one egg. That is the mass of the shell that actually contains calcium carbonate. You want to neutralize ethanoic acid. This is a very tricky question because you need to have balanced chemical equation. Ethanoic acid is CH3CO2H. Even all-level chemistry student will be able to tell you that. However, what is tricky about this is, this one, when they form a salt, this is the thing called ethanoate. That is ethanoate ion. Again, it's something that all-level student will be able to tell you. This is calcium carbonate. Calcium is a group 2 ion. When you have Ca2 plus, and this is a -1, that is the trickiest bit, okay? A lot of people will miss this one up. You need 2 of that in order to balance the charge of 1, calcium 2 plus. Otherwise, when you do the exchanging the valency, this is -1, which means the valency is just 1, and the valency is 2. When you do the exchange of valency, you need 2 of that ion and 1 of that, and you will also produce carbon dioxide, and you also produce water. Now you need 2 of the ethanoic acid, so you will have 2 there. And in terms of balancing the equation, the 2 hydrogens, 1H plus, 2H plus, give you the 2 hydrogen there. CO2, you have left with 1 oxygen. So this is the balanced equation. Do not even try to do calculation without a balanced equation. Now, in terms of the information given, this is a solution chemistry. I know it's all over the place now, but you gotta be able to do this in 1 minute, okay? This is 50 cm³. This is volume of solution. This is the concentration. So we need to think about N equal to CV, but my most favorite method is to put everything in one go, okay? We want the complete chicken shell. So first of all, we must work out how much calcium carbonate actually reacted. So the mole of the calcium carbonate divided by the mole of the ethanoic acid. Based on what I have labeled, this is mole and this is mole. So mole of the calcium carbonate, 1 mole of the calcium carbonate reacts with 2 mole of the acid. If you have gotten an equation which is not balanced, you would have gotten the wrong answer. Now I want the mass. I want the mass of calcium carbonate because one egg is 2.5 grams of the shell is actually calcium carbonate. I want the mass, then I can divide by 2.5. This is the mass of the calcium carbonate that actually reacted, and the relative molecular mass will be 100.1 because you can get that from your periodic table. Look at calcium, 40.1, and then look at carbon, 12.0. Look at oxygen, 16.0 times 3, you get 100.1. So what happened there is you get mass over MR, which will be the actual mole of calcium carbonate that reacted. Your job is to find how much mass actually reacted. At the bottom is the mole of acid. Acid is not reacting mass, acid is reacting volume of solution. So what I have is N equal to CV. So I need to do the volume in cm cube, convert that to dm cube by dividing by 1,000, and then multiply by 2.0. That is my concentration in mole per dm cube. That is my volume in dm cube. This is called mathematics. Rearrange your equation properly. Bring up the whole thing to the other side. You don't change this one. So it becomes half time 50 over 1,000 times 2.0 equal to mass of the calcium carbonate divided by 100.1. I will now bring up the 100.1 to the other side. It becomes multiplied. And then you just need to press your calculator. 100.1 times 1 over 2 times 50 divided by 1,000 times 2.0. I get 5 grams. So this one will give me 5 grams of the calcium carbonate, around 5.005 grams. So one egg has 2.5 grams. If you need 5 grams, how many eggs do you need? I forgot who asked this question. So how many eggs do you need if you want 5 grams of calcium carbonate? This is one egg. Remember, one egg is 2.5 grams of calcium carbonate. So if you want 5 grams, how many eggs are that? Sorry, who asked me this question just now? Hello? Somebody asked me this question. 2 eggs would be correct because one egg, the shell is only 2.5 grams. So if you have 2 eggs, then 2 times 2.5 will give you 5 grams there. Okay, so I hope that makes sense there. Like I said, this is a 1-mark multiple choice question. This is a real AS question. I remember this from a few years ago. It's a really good question because it involves balance equation. The first thing is people will make a mistake is here because they don't know formula. The second thing is they do their mole calculation without the correct mole ratio. And then the next thing is they forgot to convert the volume to dm cube. And then the next thing is they just randomly choose an answer. Okay, so quite a lot of mistakes that people could make. So make sure you know all of these, which are, well, year 9 or year 10 mole calculation chemistry. Okay, well, let's continue. What is the next question people want me to go through? You just shout out, okay? You shout out, then you get your question answered. Anyone? People still 13. There? 13, okay. Ooh, people always choose the difficult question. Okay, this is a long calculation question, all right? Anyway, this is called potassium dichromate 6. As you know, if you think about the potassium, you have 2 of that K+, you have Cr2 or 7,2-. This is called a dichromate 6. Very, very popular in AS, organic chemistry. This is the orange color oxidizing agent for alcohols, okay? Anyway, so we have ferrochrome. Ferrochrome is an alloy. Year 9 chemistry student would tell you that alloy is a mixture of metals, iron, and chromium. So your job is, what is the percentage of iron in the sample of ferrochrome? Only the iron will give you the iron 2+. Only the iron 2+ will get further oxidized. The chromium does not get oxidized at all because that's what they're saying. Only the iron will react with the dichromate to give you iron 2+. Now, to do this kind of question, my favorite thing is to draw. Draw and see for yourself, okay? I have 1 gram of the solid metal. What happened then is I dissolve them in acid, and then I get a solution. Do they tell us what solution it is? The resulting solution. So they don't tell us anything. So from this solution, I need 13.1 cm cube, 0.10. Oops, sorry, no. That is just the solution there. And what else here? This is iron 2+. So we can see that all of this goes into here. So all the iron become iron 2 plus. So the mole of the iron is the same as the mole of the iron 2 plus. This is solution, whereas on the left-hand side, that is mass. Oh, sorry, that is solid, not mass, that's solid. So we'll be dealing with mass of MR there. We'll be dealing with N equal to CV on the other side because there's solution chemistry. So how in the world do we solve this question? Well, we got to think about our mole ratio. Our mole ratio, there is 6 mole of Fe2 plus, 1 mole of Cr2 or 7,2 minus. Our goal really is find out the mole. The small n there refers to the mole of iron 2 plus. So a lot of this calculation, you see it won't make sense. Yeah, you need to really sit down and do it on your own later on. Unless you can do it on your own, this session will have been useless actually. So 1 mole of Cr2 or 7,2 minus based on your label. I've labeled it as such, but if you know mathematics, you can put this on top and this at the bottom. You just follow your label. Here, the iron 2 plus is on top. So 6 mole of iron 2 plus, 6 mole from the balance equation reacts with 1 mole of the dichromate. On the right-hand side, I will put in the information that I need, okay? I just need the mole of the iron 2 plus, which is the same as the mole of the Fe solid. You see, the mole of iron solid is the same as the mole of iron 2 plus. According to this diagram, all of these go to there. So this is equal to the mole of the iron, but the mole of the iron is also equal to the mass of the iron divided by the MR, which let me just pull out my periodic table. I think it's 56 point something, 55.8. So that is 55.8, not 56. So that is mass over MR. That is straight to the iron because the iron 2 plus is related to the mass of the iron. So I could put that straight away in there. So that's how I can get that. All right. At the bottom, I have N equal to CV because this is volume. This is concentration. We are talking about solution chemistry, something you will have done in your titration, probably your entire life. So convert the volume into cm cubed, and your job really now become mass of the iron divided by 55.8. Don't change anything on the other side. So it's 6/1. So this is all mathematics. Unfortunately, if you can't do this simple rearrangement, then you will always struggle with some more complicated mathematics. I'm going to move up the 55.8 to the other side. It becomes multiplied because this is divided by 55.8. So I'm going to move that up and it's going to become multiply. You can do that on my screen easily. You might need one more step on your paper. But again, this is multiple choice. So just because it's multiple choice doesn't mean that you shouldn't show your working, because I don't know, I mean, like a few minutes later, you want to check back your work, but then you forgot what you did from the very beginning. So it's better that you check your work and write down the working. Later, it will make your life easier to check the work. This is the mass of the iron in the mixture. Your mixture has 1 gram. This is the mass of iron in the mixture. So they want the mass of iron. So that is going to be 0.4386 divided by 1.00 gram times 100%. That is your percentage of iron. So that will be 43.9%. Okay, so hopefully that makes sense there. All right, so hopefully that answers your questions. Should we go for the next question? I mean, 1 hour is pretty short, yeah? So I'll go through as many questions as you want me to go through. Any next question? Here for you. Don't have to be shy, okay? Don't have to wait for your turn, Whoever just shout out for whatever question you want me to go through, I'll go through it. But again, it's a calculations set of questions. Until you actually do it on your own, it won't really help you that much if you can't do it on your own. Okay, any questions at all? Are my connections lagging? Because I can't hear anything at all.
8.
Question 8. Question 8. All right, so question 8 is a lot simpler than the earlier questions. So this one is Let's see. This one is room temperature and pressure, right? Room temperature and pressure. We know even from your data booklet, in your predict table, they tell you that this is 24.0 dn cube per mole of the gas. This is per mole of one gas. 1 mole of any gas occupy this much volume at room temperature and pressure. So at the same temperature, at the same pressure, so this means this is not ideal gas. If the temperature changes, if the pressure changes, then you use ideal gas equation. But it is still the same condition, so we don't need to use ideal gas at all. In terms of that, they want a volume of 6 dm cube. So the first thing I do is, if you have 1 mole, you have 24 dn cube, or 24 dn cube is 1 mole. So therefore, 24.0, if you think about it, yeah, okay. So let me just make something really clear. 1 mole of gas has 24.0 dm cube. So if you have 6.0 dm cube of gas, how many mole of gas do you have? This is the direct proportion. So this will give you 0.25 mole of gas. Now that is mole. All of these are masses. So to relate mass and mole, you need mass over MR. To do the MR, well, you need your periodic table. The MR of O2 is 32.0. The MR of N2 is 14.0 times 2, 28.0. The MR of SO2, so 32.1 times, plus 16.0 times 2, 64.1. The MR of CO2, 12.0 plus 16.0 times 2, 44.0. I'm probably just wasting my time to calculate all of this MR, whereas I should be spending my time to get this answer first. Only then I should go through all the other MR. So for the first one, mass over MR, 3.2 over 32.0. The mass in gram divided by the MR, 32.0. Well, definitely it's not 0.25 because I got 0.1. So that means A cannot be the answer. How about B? B is 5.6 over 28.0. I think I should get 0.2. So this is again not the answer. How about C? 8 gram divided by 64.1. 0.125. Again, this is not 0.25 mole, so that cannot be the answer. But for D, well, if A, B, and C cannot be the answer, after I did my calculation correctly, just double checking, 11.0 gram divided by 44.0 is 1 over 4 is 0.25 mole. So hopefully you can see why D is the correct answer there. Okay. All right. Ready for the next question?
Question 3.
Question 3. Question 3 is a calculation question. So what you can learn from me today, okay, the most important thing you can learn from me today is learn to set up the mole ratio in one step, okay? This is mole of N2O4. This is what you want. This is NaOH. This is what you want. This is 1 mole reacting with 2 mole. In the old days, you probably do this in 2 or 3 steps. What I'm showing you is a shortcut. Just make sure you label. So the mole of, so you want the NaOH, so the mole of NaOH on top over the mole of N2O4. I've never made a mistake with this, yeah? I never made a mistake with this because it's always clearly laid out. It's just mathematics. If I put the mole of NaOH on top, I look at the balance equation, 2 mole of NaOH, so 2 on top here. Mole of N2O4, 1 mole at the bottom, according to your label. This is equal. So that means whatever is on top is on top, whatever is at the bottom is at the bottom. If you got them the other way around, no problem. Then you will get 1 over 2 because you know how to read your own handwriting. On the right-hand side, this is from the balance equation, but this is equal to the actual amount that reacted, This is the actual mole. If you look at the quantity, the question says mole. So I don't need to do anything. It's just 0.02 mole already. It's not volume, it's not concentration, it's mole. So put in just mole. On the top here, I want the volume. I want the volume of solution. Look at the unit, they are all in cm cube. If they are all in cm cube, so this volume in NaOH, which is in cm cube, must be divided by 1,000. Dividing by 1,000 is the same as multiply by 10 to the minus 3. That is just mathematics, okay? So that is the volume. And don't worry, this is volume in dm cube, it's not mole. So the volume in dm cube must be multiplied by the concentration in mole per dm cube. N equal to CV. Number one mistake is people forget to convert the volume into dm cube then. So these are the volume in cm cube according to the question. So my job is find or make volume of NaOH the subject of formula. Bring up that thing to the other side first. 2/1 times 0.02. So you get volume of NaOH times 10 to the minus 3 times 0.5. However, this is multiplied by the whole thing. So what I can do is I can bring all of that down there and I will have a big divide, okay? Because that is just mathematics. So I hope that makes sense to you. Okay, rearranging equation, very, very important in mathematics, very, very important in physics as well as biology and also chemistry. So do the top bit first. So 2 times 0.02, 0.04 divided by bracket 0.5 times 10 to the minus 3. I get 80. And don't forget, this is volume. This is the volume in cm cube. That was why I multiply by 10 to the minus 3, which is the same as dividing by 1,000 because this is the volume in cm cube. So that means I have a unit of cm cube. So there's 80 there. Okay, so I guess the most important thing you can learn today is learn how to use to set up expression like this, and you will never go wrong again as long as you can do mathematics. All right, next question. We don't have to go through MCQ. We can go through structure as well. It's really up to you.
Sir, the question 3, the structured one.
Question 3, structured one. Structure are usually longer, yeah. Question 2, question 3 is really long, no? I tell you what, why don't everyone turn on your camera first, and we'll take a group photo now, just for attendance sake, and then we'll just continue the question later on. Okay, so just turn on your camera for the time being, and let's just quickly take a group photo, and yeah, we'll move on again from there. All right, so let's just turn our camera on for, I don't know, a minute or two. Okay, Afif, are you still confused? I hope not. Okay. Well, I mean, like it's calculations, right? So a week in advance, I'll pause up the work. I think just waiting for Akila now. A week in advance, I'll pause up the work, and it's really okay. Smile. Akila is here. 1, 2, 3. Smile. Another one. 1, 2, 1, 2, 3. Smile. All right. Okay. We'll stop the video, and yep, we can get back to the real chemistry. So I'm not too sure how intuitive this is, yeah. So I haven't really asked a lot of questions this week for you because with calculation is a bit tricky, right? But I guess here is where we'll probably ask you to do a couple of things, right? So see whether you can balance this equation in 1 minute. You must be able to balance this in 1 minute, and then I can ask any of you in 1 minute time. Okay, try balancing this in 1 minute first. So ammonium sulfate and any sort of hydroxide will give you ammonia gas. This is the test for ammonium ions in the lab. All right, you try the balancing equation on your own first. If you have finished, you can do the next bit as well. So in about 1 minute, you should have finished balancing the equation. Yeah, this is a O-level kind of balancing equation. It is an AS question, but you must be able to balance it in like 1 minute. Hello, Isa, are you there? Have you gotten your equation balance?
No.
No? Oh, you're working really slow, okay? AS doesn't work for anyone, okay? It doesn't wait for anyone at all. Shakira Kolani, yes, because I have 2 Shakira. Have you gotten your equation balance yet?
Yeah.
Okay, that's good. All right, you tell me, what are the other 2 products first of all?
K2SO4 and water.
That is correct. So you do get a salt and you do get water. So this is a classic reaction, okay? This is the ammonium salt. When you have ammonium salt, doesn't matter, ammonium sulfate, ammonium nitrate, with any sort of hydroxide, any sort of hydroxide, like metal hydroxide, typically, you will get ammonia gas. This is one way of producing ammonia in the laboratory. You get a metal salt, you do get water as well. Okay, a classic thing to test for ammonium ion, NH4 plus OH minus will give you the NH3 and H2O. This is an ionic equation. Typically, it's worth 2 marks, whether you're in practical or whether you're in theory paper. You think about what is happening here. The NH4 plus is losing H plus, so it's a H plus donor, whereas the OH minus is gaining H plus or accept the H plus. This is a H plus acceptor. This is a base because a base accepts protons. This is an acid because an acid donates proton. It donates the proton to that, and then you get this product, okay? After the acid donates the protons, you get the conjugate base. After the base accepts the protons, you get a conjugate acid, okay? These are from your acid-base equilibrium topic in AS chemistry. This is an important equation. This is the gas that you test for with red litmus paper, and it will turn from red to blue when it's a little bit moist as a result of these two reactions there. This is called a neutralization. That equation, the ionic equation, looks a bit different from this one because these are the spectator ions. All potassium salts are soluble. That's why, you know, K plus SO4 2 minus appear on both sides of the equation. Spectator ions, we don't show them in ionic equation, but this is a full balance equation, so we have to show them. So how many mole of KOH do you get, Shakira?
2.
2. How many mole of NH3 do you get?
2.
2. As you could see, the KOH give you the K2SO4, so 2 potassium there give you 2. Why do we have 2 NH3? Because we have 2 ammonium. 1 ammonium give you 1 ammonia. 2 ammonium give you 2 ammonia. Okay, how many water do I get, Shakira?
2.
2, because again you have 1 ammonium give you 1 water, 2 ammonium give you 2 water. It's just multiplying this equation by 2 there. Okay, so hopefully that your equation is balanced now. So you, just like that, you get the 2 marks. Easy start to the question. The next thing is, this is a long question. It's actually part of a practical question as well. You can imagine. Draw and see it for yourself, okay? This kind of questions, I always insist on drawing. Not a great artist, but I can draw. I can draw some simple diagram so that I can see what is going on. So I boil it with an excess of KOH. If I use excess KOH, all of the ammonia gas liberated comes from ammonium. They comes from the ammonium sulfate. That means if I use excess of this, all of this will react, and all of this will give me my ammonia, okay? And this ammonia is absorbed by this HCl, which again is in excess. So here it means all the NH3 reacted, okay? Whereas the previous bit, it means all the ammonium salt reacted. So you got to learn to interpret information. You don't really have to write all of this down, but you know, it's important for you to make note so that you remember what your brain processed just now. So what happened is, I will have ammonia solution, but then this one will react with HCl. So this one reacts fully with the HCl, and the HCl is in excess. If the HCl is in excess, that means my resulting solution is, this is the excess HCl plus NaOH titration. So that is the very last thing that we are doing here. We are titrating the excess HCl with the, where are we going? Hang on, no. This is 50 cm cube of 1.00 mole per dm cube HCl. I beg your pardon, not yet. I think I missed one step. So from here to there, you need to dilute. Diluted. So what happened then is you will get 250 cm cube of the diluted excess HCl. Here you only have 50 cm cube. Well, actually not 50 cm cube. I just leave it there. Okay, and from here, you only take out 25 cm cube for titration. So I know my diagram probably doesn't make much sense at the moment, but let me just run you through the process. The solid reacted fully, give you ammonia. The ammonia reacted with excess HCl. So all the ammonia is gone. You have excess HCl in here. But the thing is, you don't have that much. So what we do is we transfer to a volumetric flask. This is called a volumetric flask, something very common in your practical science, and you will learn to label apparatus again in paper 3 or paper 5. In a volumetric flask, a 250 cm cube volumetric flask, you make it up to exactly 250 cm cube. And from there, you take up 25 cm cube for your first titration. We don't use all 250 for titration because you will need a lot more volume in your burette. So what we do is we do the first titration, and then we can do a couple more titration because 250, each time you take out 25 cm cube, you can do at least 10 titration. One rough and 2 or 3 exact titrations will tell you your accurate result or not. Now, what we're going to do is, this is called backward titration because this is where you start. This is where you start, and then you're going to use that to work that. Oops, sorry, I was going to use the highlighted. This one to work that out, and that one to work this one out, and that one to work this one out. It's called backward titration. You can always find out more on YouTube. When you Google backward titration, you can find out a lot more problems around this kind of scenario. These kind of questions, they try to guide you one by one, step by step. So let the question guide you, but at the same time, try and think about the question as well, yeah? So we're starting from here. We're starting from the titration, and we're trying to work backward. So this is mole of KOH in 20 cm³ of the KOH. So if you have 20 cm³ of this, and your concentration is this, how do you find the mole of KOH here? I should probably ask someone on this. Let's ask Afif, are you there?
Yes.
How do you find the mole of KOH? Tell me, what would you do? And I'll write it out for you. Do you know how to find the mole of KOH? Volume of KOH for your titration. Concentration of, so can you tell me what would you write down?
0.1 times 20 tapi ubah dulu ke dm cube.
How? What would you do?
Times 10 to the power of -3.
Yep, that's correct. Or you can do divide by 1,000. It's the same thing. So if you try and do this on a calculator, because there's not much point of just looking at me doing on the screen. Now, this is what your calculator will show you. This is what your calculator will show you. If you go back to the stoichiometry and calculations topic in the syllabus, okay? The syllabus will tell you A level or AS level students should be able to tell what is appropriate number of significant figure. I'm sure you have been told about this, especially in practical, as well as in all the calculation questions, what is appropriate number of significant figure. In the data, 1, 2, and 3 sig fig, 1, 2, and 3 sig fig, 1, 2, and 3 significant figure. So these are the data presented to you. Your calculator does not have the ability to think in terms of significant figure. They'll just give you a number like this. Unfortunately, if you just don't think on your own, then your calculator will never guide you on the idea of appropriate number of significant figure as stated in the syllabus based on the data. Not always 3 sig fig, but based on the data given in the question, okay? So I give this to 3 sig fig there. Now, if that is the mole of KOH that reacted, we are still in the 25 cm³ titration, yeah? So we use 25 cm³ HCl. There was whatever was pipette out. This was whatever was in the burette, I guess. So what is the mole of HCl here? How do you find the mole of the HCl that reacted with the KOH? So this is the HCl that reacted with the KOH. So what is the mole of the HCl that reacted with the KOH? Yasmin. What do you think, Yasmin? Are you following this scenario?
Yeah, it's 1-to-1 ratio, so the mole is the same.
Okay, it's 1-to-1 ratio, so they are exactly the same. You could be thinking about the mole ratio, which I've shown you, but there's not much point because this is already in the simplified 1-to-1 ratio. So this is exactly as the same mole of KOH reacted. So it's 2.00 times 10 to the minus 3 mole as well. I'm maintaining the same appropriate number of significant figure throughout my calculations based on the data provided. Now, this is the tricky thing. This is the amount in mole of the HCl. This was present in excess. Remember, it was used in taking up, in absorbing all the NH3. Then I have excess HCl. Then I make it up to 250 cm cube. So we are here now. We are here now. So we are here now, but we started from here. So in 25 cm cube, you have this much more. In 250 cm cube, do you have more mole or do you have lesser mole? What do you think? Shakira with the H. Are you there, Shakira?
Yes.
All right, so how do you work out the mole of the HCl in here? You are starting from here. How do you work out the mole of the HCl in here? So this information is for this one here. But you want the mole of HCl in here. What do you do? Use your answer to B part 2, right? Well, the rest of you try as well. Don't wait for Shakira. Any idea, Shakira?
Cross multiply.
Okay, so is it going to be higher or lesser? Is it going to be more or lesser more? You are
Less.
here, so you are here, and now you have a greater volume. Okay, do they have the same concentration or do they not have the same concentration? Remember when you do titration? Okay, when you do titration, you make up in a convolumetric flask, right? You bring your pipette and you take out 25 cm cube. Okay with me so far?
Yeah.
When you do your second titration, you take out from the same bottle and then you put it in the second conical flask and then you repeat your titration. You keep on taking from the same bottle. So this one comes from here. Do they have the same concentration?
Yes.
So they do have the same concentration, okay? N equal to CV. If C is concentration and it's the same, so you see the key thing here is same concentration. If the concentration is the same, so that means N is proportional to V. So like you said, cross multiply is correct, but you have gotten a wrong concept where you say it will be lesser mole. Because when your volume is greater, you will have more mole. Higher volume, greater mole when the concentration is the same. It's like Ribena. When I have a whole bottle of Ribena, I just pour it into 10 cups. Each cup comes from the big bottle of Ribena, but each cup has been split up from the same Ribena bottle, so each cup will have lesser Ribena compared to the original. So in 25 cm cube of HCl, I have 2.00 times 10 to the minus 3 mole. So in 250 cm cube of HCl, so I would definitely have greater number of mole. So I will have 250 divided by 25. This is called a factor of 10. So you can see 250, I take out 25. On your calculator, it should tell you 2.00 times 10 to the minus 2. I don't think that's what your calculator will show you. Your calculator will probably show you 0.02. Again, if this is what your calculator show you, this is only one significant figure. You should really be wiser to do 3 significant figure. So both of these will be correct. But I usually just prefer this because I'm just working with standard form. Okay, so far, Shakira, can you understand this?
Yeah.
Your cross multiply just now, you were getting confused about the concept, yeah? So you need to be very careful with what you're saying. Now we are here already, and we are ready to jump into here, I think, okay? So we are slowly working backward. It's called backward titration. Now this is the amount in mole of the HCl, initially mean at the start, before you react, before reacting. Here the information is given. The information is given 50.0 cm cube and 1.00 mole per dm cube. So I probably won't ask you anything on this, but let's just see CV, so mole per dm cube. And then just like what Afif said, you need to remember to convert the cm cube to dm cube. So some students always forget that. You divide that by 1,000 and you get 0.05. That is what your calculator wants you to believe. 3 significant figure to be consistent and also appropriate in your number of significant figure. Look at the data, 1, 2, 3. 1, 2, 3, and the rest of the data before, 3 significant figure as well. This is the HCl you put in. This is the HCl you use to absorb this is used to absorb the NH3. Okay, you use this in excess. This is in excess, use it to absorb NH3. After you absorb the NH3, you use excess acid, you have extra acid. The extra acid is made up to 250 cm3. How much acid remains in here is this. This is the remaining HCl, which is unreacted. Unreacted after you use it to absorb all the NH3, you have excess acid. How much mole of acid is here? You have 0.0200 or this much more. But you know how much acid you put in. So how much acid you put in minus how much acid remaining would be how much acid actually reacted with the NH3. This is reacted with the NH3 because we put in this much. This is what you put in. It's in excess. What we use. How much reacted is going to be what we use minus how much remaining. How much remaining was what we use for our titration, not in the 25 cm3, but in the 250 cm3. So you've gotten 0.02 mole remaining. Hence, this is what you put in total. This is what you put in all together. Take away how much remaining. This is remaining, which is what you use for your titration with KOH. Okay, remaining at the end of reaction after you absorb all the NH3. This is what you use total. So this is the mole of the HCl used to absorb the NH3. So this is going to be 0.03 on your calculator. Again, your calculator does not have the capacity to think, so you need to be very careful there. Now this next one, the number of mole of NH3 produced, how much NH3 get produced is being absorbed by the mole of the HCl that reacted, because this is the mole of HCl that's used to absorb that. As you know from the earlier equation, NH3 plus HCl, base plus acid, this equation was given earlier as well. You get this salt called ammonium chloride. In this salt, what you don't have is, in this neutralization, you don't get water because the ammonia there is already dissolved in water. You do get water as a result of using aqueous ammonia there. I mean, the ammonia was produced as a gas, but then it will dissolve in the water of the HCl, so you do have water already in the system to begin with, yeah? Just so you know. So using these equations and your answer to that, what is the mole of ammonium sulfate that reacted? Seems like that has skipped one step, but I'm just going to tell you. So the mole of the ammonia produced, that's what they're saying, is going to be equal to the mole of the HCl used to absorb the NH3. So this is 0.0300. Now using the correct equations, because now we are going even further, we're going to the very, very beginning, the one that I think I asked Shakira or someone to, I think I asked Yasmin to do this just now earlier. So the mole of the ammonium sulfate is to the mole of the ammonia. From your early balance equations, your very, very, very beginning balance equations, 1 mole of ammonium sulfate give you 2 mole of ammonia. 1 mole of ammonium sulfate give you 2 mole of ammonia. So 1 mole of ammonium sulfate give you 2 mole of ammonia. That is from the balance equation. We just want the actual mole of ammonium sulfate that reacted. So this is the actual mole of the salt of the ammonium sulfate. The mole of ammonia that get produced is 0.0300. So what I do is I just cross multiply. Well, not really cross multiply because I'm not doing proportions. I'm just rearranging my equation. I better use my word carefully. I'm rearranging my equation. So I get 0.015 mole. I'm sorry, is anyone lost at the moment? Do you understand what I just did? Can you speak up if you are lost, if there's anything you don't understand at the moment? Is everything okay, everyone?
Yes.
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 All right, okay. So the whole idea is not to go through as many questions as possible, but also to make sure that you understand because once you understand how to do one, you should be able to apply the same concept, such as, drawing the kind of simple diagram I drew, labeling your stuff properly, and not just randomly, putting in your working or whatever. Now I have the mole of the ammonium sulfate. I want the mass. I'm given MR. So now this is mass of MR equal to the mole of the salt. So the mass of the salt is going to be the mole, which is 0.015 mole, multiplied by the MR, because I just move out the MR as I want the mass of the salt. The mole is there, the MR is there. So what you do is you just use your previous answer, and you can get this as 1.9815. This is what your calculator show you. Again, this is not appropriate. In fact, this is already not appropriate. I have used what the calculator showed me. It should be 3 significant figure, 1, 2, and 3. Similarly, for this mass, I have to round it up to 3 significant figure. This is called appropriate number of significant figure. You would have learned about this as you were doing practical chemistry in paper 3. Okay, now the ammonium sulfate fertilizer. Fertilizer is a mixture. The mixture there, the solid we used earlier, consisted of 6.60 gram of fertilizer. But the fertilizer contained ammonium sulfate. Only the ammonium sulfate will react with the KOH and give you all the subsequent reaction. So out of 6.60 gram, only this much is ammonium sulfate. So the percentage by mass or percentage purity of the fertilizer, of the ammonium sulfate fertilizer, is just going to be the mass of that, 1.98 divided by 6.60 times 100%. I get 30 on my calculator. By right, it should be 30.0% to 3 significant figure. Okay, I'm not saying that you will get penalized every time you don't have the 3 significant figure, but out of 10 marks, there's probably 1 mark for significant figure, just like there's 1 mark for appropriate number of significant figure in your paper 3 chemistry, your practical chemistry usually as well. Okay, so that's it ready for this question. So I don't know, we have around 8 more minutes. Any further questions you want to ask? Anyone? Just shout out.
11.
11, was that back in MCQ?
Yes.
All right, so, okay, so in this question, I think you must have learned this thing called balancing equation. I think this is oleum, if I'm not mistaken. S2O7 is actually oleum. So you are on the last step, the very last step of contact process, something you will have learned in O level. But in O level, they don't focus on this so much. Doesn't matter. Write a balanced equation. You cannot expect to do a calculation question without a balanced equation. Write the balanced equations. So all of you should try this first. Why don't all of you try this? So follow the question. Plus water, hydrolyzed by water means it reacts with water. It gets broken down by water. Sulfuric acid is H2SO4. The other product is oxygen. So balance these equations for me. So this is 1 minute for the whole calculation. Yeah. So balancing equation should come like what, 10 seconds? Akila, did you manage to balance this equation for me?
Yes.
All right. Okay. So what is the first thing you would do?
2S2O7.
Nope. Because what you just said is if you put 2 there, surely they give you 4, right? But you only have 1 there. Okay, let me tell you how I will balance my equation. Okay, you might be right, okay? But the most important thing in balancing equation is focus on the smallest number. Focus on the smallest number. It will make your life easy. 2 sulfur, 1 sulfur. So the first thing I would normally do is put the 2 here, because then I'll get 2 sulfur. Follow so far, yeah? The next thing I would do is, there is no hydrogen, there is 4 hydrogen. If there's 4 hydrogen there, I should put a 2 in front so that to get 4 hydrogen on the left-hand side. Follow so far? Okay, keep the smallest number, yeah? Now, altogether, your oxygen on the left-hand side, 7 oxygen. 2 times 1 is 2 oxygen. So 7 plus 2 is 9 oxygen. 9 oxygen on the left. Here you have 8 oxygen. You see you have 8 oxygen. You want 9 oxygen. But this is 1. 1 times 2 is 2. 8 plus 2 is 10. What do? I just need 1 more oxygen atom. I need atom. I cannot change the molecule, what I can do is do a half. You will have learned about fraction anyway, right? This is what you will have learned in enthalpy of formation and stuff. You can use fraction. Balancing equation is just number. Okay, I can use fraction without changing the identity. A half times 2 equal to 1. So there is 1 oxygen atom in this half oxygen molecule. Okay, you might be right. You might be right in putting a 2 in front, but you'll be dealing with a big number. Big numbers are more scary. Big numbers make you slow. Big number slows you down. Always work with the smallest number, then you can be much faster in balancing equation. Okay, I'm not saying you're wrong, yeah? You might be right, but it will be much faster if you can balance the equation faster. The next thing is you want the volume of oxygen. So that means we want this, and we want a gas. So this is a gas, and it is measured at room temperature and pressure. So go straight to molar volume of gas, which is 24.0 dm cube per mole of the gas. When you have this much mass of S2O7, this is called reacting masses. So you need mass of mR, and therefore you need to work out the mR of S2O7. If you look in the data booklet, 32.1 for the sulfur, and you have 2 of the sulfur, and then 7 times 16.0, I get 87.2. So here's where I'll set up my equation, all right? So look carefully. The mole of oxygen is to the mole of S2O7. This is what I want. This is what I'm given, okay? Follow the mole ratio from the balance equations, that you just did. 1 mole of S2O7 give you half mole of O2. The O2 is on top, so I put the half on top. So this is a half on top, 1 mole of S2O7, 1 at the bottom. Akila, if you had gotten a 2 just now, you have gotten 1. So you would have put 2:1. Sorry, 1:2. Doesn't matter, it's the same thing. It's mathematics. It will give you the correct answer. On the top here will be the mole of O2, but I want the gas. So when I want the gas volume in cm cube. Have a look at the option. They are all in cm cube. If they are in cm cube, I can use the 24,000 cm cube per mole. This is equal to this because dm cube convert to cm cube is multiplied by 1,000. So this is the volume of O2 in cm cube divided by 24,000. So I'm very clear. This is the volume of O2 in cm cube divided by 24,000 cm cube per mole. At the bottom, this is the mass, so 0.352 gram divided by 87.2 there. So what we do then really is move that up. So on the other side, a half divided by 1 is just a half, multiplied by 0.352 divided by 87.2, equal to the volume of O2 divided by 24,000. As I'm doing it on the screen here, I can move the divide by 24,000 to the other side. I get multiply. So what I get then is, I just need to press my calculator. 24,000 times a half times 0.352 divided by 87.2. I get 48.4. So the volume of O2, I get 48.4. This is in cm cube because I have done division by 24,000 cm cube per mole. So this is in cm cube. Do not forget your units. Value and units are very important in calculations. The answer will be C then. Okay. Well, it's 9:45 now, so I think that's it already for this 1 hour session. I don't know. I mean, you should probably try the rest of the question yourself. And if, like last week's one, I'm going to set Wednesday as the deadline if you want me to check your work. So do send them in by email before Wednesday, and then I'll have a look at the work. But I mean, it's calculations. There's not much point of me showing you how to do if you can't do it on your own. So you need to practice the method, especially this kind of mole ratio method. I didn't learn this from anyone, actually. It was just through trials and error previously as I was learning through mole calculation. Previously, students would just do step by step, right? This is more advanced than that, but it's faster because you can see, you set it up from the mole ratio, and then this is from the balance equation. This is just level. This is from the balance equation per your level, and then these are depending on whether you have mass over mR or N equal to CV or volume of gas divided by the molar volume of gas there. Okay, I don't think I'll keep it any longer because you have another class coming up. So yeah, thank you everyone. I have recorded the session and I will share this recording later on my YouTube channel, and you can always go back to it if you ever need to, run back through some of the concepts we cover. Does that seem all right, everyone?
Yes.
Yes.
Okay.
Sir.
All right. Okay. Cool. All right. Have a good day. See you guys next week. Okay. So Wednesday is the
Thank you.
deadline if you want me to check your work. Yeah. So Wednesday is the deadline if you want me to check your work. Okay. All right. See you guys. Bye bye.
Thank you.